So today I'm going to talk about Pythagorean identities. There are three Pythagorean identities. I'll just write one here for you first, so you know what I'm talking about. Right, so this is an example of a Pythagorean identity. So this identity is very important, okay? These three identities are really important. So you'll probably need to use them at some point in proving equations or solving them. So I'm going to teach you how to derive them. Okay, I'm going to teach you two ways, but before I talk about the Pythagorean identities, I have to talk about the reciprocal identities. The reciprocal identities are pretty straightforward. You should know this by now, okay? They look like this. Okay, now most people don't have problems with tangent and cotangent because it's pretty obvious, okay? They both have the word tangent in it. But some people mess up sine, cosine, cosecant, and secant. Now, there are two ways to remember this easily. The first one is simply S and C. Each pairing has one S and one C. Okay, so basically, if I have sine here, the reciprocal cannot be secant because they're both S, right? So the reciprocal has to be cosecant because obviously sine and cosine are not reciprocals of each other, right? So this is one way to remember it. Another way to look at it is that each pairing has the word co in it, and this word co occurs exactly once. So that means if I have sine theta, I cannot pair this with secant because there's no co in it, right? Similarly, I cannot pair cosine and cosecant. There are two cos, right? So here, sine has to be paired with cosecant, cosine has to be paired with secant, tangent is paired with cotangent. Okay, so these are some quick ways to remember your reciprocal identities, although you should know them by heart by now. Now, on to the Pythagorean identities. I'm going to teach you the first way. The first way is the more efficient way, okay? So the first way, all you have to do is to write sine here, cosine here, and tangent here. Now, the position of this three, you have to memorize them, okay? The rest you just derive. So the reciprocal of tangent is cotangent. So I'm going to write the reciprocal on the opposite end. I'll do this for sine and cosine as well. So reciprocal of sine is cosecant, and the reciprocal of cosine is secant. Now what I do next is I just draw a straight line passing through like this. Then I put 1 in the middle. And then I'm done with my diagram. Now how to read this? Basically, you just need to look at these triangles. Mini triangles, okay? So sine square plus cosine square is 1 square. So the square of this plus the square of this is the square of this. The square of this plus the square of this is the square of this. Same for this, right? But 1 square is 1, so we can just write it like this. Right? And the next one. Easy and fast, okay? So we're done with this first method. I'm going to talk about the second method. The second method is a little bit more fundamental, okay? And it takes a longer time to actually derive it. So you may not want to really do this in the exam, but I think you should know how to do this, okay? Because this is fundamental. So now this is a right angle triangle and theta is here, so we know that this is opposite, this is adjacent, and this is the hypotenuse side, right? Also, by Pythagoras' theorem, we also know that O square plus A square is H square. Okay? So that's why these identities are called the Pythagorean identities, okay? Now, I'm going to split this into 3 cases, okay? And I'm going to divide the equation by the square of each side. So I'll illustrate this in the first example. Let's divide by H square first. Okay? Now, by simple algebraic manipulation. H square over H square is simply 1, right? O over H, what is O over H? Sine. What is A over H? Cosine. Right? Okay? So this is the first Pythagorean identity. Okay? You should know this by now. I'll just write this at the side. Okay, now, what about the reciprocal identities? Do you know what cosecant theta is, secant theta is, and cotangent theta is? Now, because this is reciprocal of this, so the fraction, you just write is reciprocal, right? Reciprocal of O over H is H over O. Same for this, H over A. And the last one is simply A over O. Okay? I'm writing this because we will need to use this later. The second part here, let's just divide by O square. It's 1 A over O square H over O square. Okay, so what is A over O? Okay, it is simply cotangent. Right? What is H over O? It is cosecant. Right? In the event, you don't want to do this, A over O, you just need to know that A over O, just simple algebra, right? It's just 1 over O over A, which is also 1 over tangent, which is also cotangent. Okay, there's another way to think about it. It's just algebra. Now, I'm going to talk about the third point, the third identity I mean, which is this. If I divide by A square, okay, so this is just O over A, right? This is 1, this is H over A. O over A is easy, it's tangent, right? H over A. So again, let's look at this. It is secant. Okay, so there we have it. Our 3 Pythagorean identities. So if you want to, for efficiency, right, and for practicality, you might want to use the first method. The second method is good to know, maybe not so effective in the exam. So that's all for today. I hope you learned something new.